Okay, Advent of Code Day 9, here we go. Let's get our input, and it's giving me an int list. Wow, that's some big numbers at the end there. Just print it. Great, we've got our list. Okay. Starts with preamble of 25 numbers. Find the first number of the list, which is not the sum of two of the 25 numbers. What is the first number that does not have this property? Okay, so for loop. For num in L. Well, let's do for. We're going to have to index I in range. We're going to have to start with 25 because that's the 26 number. L for J. So past false. J in range. I minus 25. I for K in range. Then we want the smallest value to be J plus 1 I. If L of J plus L of K equals L of I past equals true, if not past, print L of I. Wow. Okay. Invalid. You must find a contiguous set of these. Okay. Sorry. One more time. Find the contiguous set of at least two numbers in your list which sum to the invalid number from step 1. Okay, so for this, we're going to iterate in range 0, L, or J in range I plus 1, length of L, and then we're going to say we need to sum that range. Then we need a if sum of L of I J. Well, we want this to be J plus 1 equals ands, then smallest and largest, print min L I J plus 1 max L I J plus 2. Or sorry, J plus 1. Oops, didn't mean to do that. Not the right answer. Dang it. Okay. So let's slow down for a second and actually figure this out. Let's print out the why didn't this work? Okay, let's read this carefully. Take a contiguous set of at least two numbers which are in your list, which sum to the invalid number from step 1. This list, adding up all the numbers. Wait. Oh. How did it? Oh, I copied the wrong number. And we just missed top 100. Oh, oh, how rude. Okay, well, I am stoked because this is the first time that I got into top 100. I got points. Yay! That's so exciting. And I would have gotten points here too if I hadn't copied the wrong dang number. Okay, well, that's a rush. That's really exciting. So let's just quickly talk about what we did here. And I'm going to get rid of all these extra prints here. And let's just put a print of part 2 solution and print part 1 solution. And actually we can add a little break here to make that go faster. And then also we don't need to iterate through all this because once we find the solution we can just leave. Thing is we have to let's see here, let's say ands 1, ands 1, ands 1. And let's say ands 2 is equal to 0. And then this is just to make it run a little bit faster. Yeah, that's a little bit quicker. Man, I can't believe I just copied that wrong. That's infuriating. Okay, well, pretty quick, but let's talk about what happened. So this first bit was literally just a big list of numbers, as we can see, and every single the first 25 numbers are just kind of set in stone, and we ignore them because it's the preamble. But after that, every single number needs to be a valid sum of the previous 25 number, of 2 of the previous 25 numbers. So what we do there is we say, okay, well, let's look through every single index in the entire array, starting at index 25, which is the 26th number, and we say, nope, you haven't succeeded yet, and then we iterate through the previous 25 numbers, where we indices, where we say, okay, J iterates through the previous 25 indices, and then K iterates through everything after J. because we don't want to retry the same pairs just for speed reasons. It's not super important here because we're only iterating over 25 things every loop, but every little bit counts. And then we just say, okay, well, if those two things are equal to that, then past equals true. And we can add a little, we can even make it a little bit quicker here if past break. Not that that matters because part one was the one that was already super quick. So that's all fine and dandy. And then for part two, what we were doing was we were looking, or sorry, so for part one, we're looking for the one where it does not pass. Because it means that we didn't find a successful pair of the previous 25 numbers that caused it to pass. So we record it and break. And then for part two, what we do is we keep track of this answer one, and we iterate through every single possible start and end index with its at least two numbers. So that's why we go through 0 through length of L. And this could actually be length of L minus 1 because for the starting index needs to have at least one number after it. And then this one starts at the index immediately after I and ends at the last index of the list. So and then what we check is we check that entire range right there, ranging from the ith element to the jth element. We have to do j plus 1 because the end is exclusive, not inclusive. We could probably modify this so that we don't have to deal with this weird j plus 1 thing. Let's actually think about that for a second. So if we actually just start j at I plus 2, that's a little bit more confusing, like understanding wise, because this is like the exclusive end of the thing. So, but I think that makes sense. In this case, yeah, let's try this. Yeah, I actually think that this avoids a nasty case where if it ends at the very, very end of the list, which it's actually not possible for that to do. No, it might be possible. I don't know, but like mathematically, it's a little bit funky because the numbers at the end of the list are absolutely massive. But now we start at I plus 2, and so now the smallest value that this could be would be length of L is what we want. So that should be minus 2. It's going to work because I don't think it's dealing with this edge case, but let's think about this for a second. So I can go all the way up to, say we have a list of 3 elements, 0, at index is 0, 1, 2, then the range that I can be is, the range is 0, 1, which means that I can only be 0, which I don't buy. I think that's just minus 1. And then J can be the length of L. That's where the little distinction had to be made. So we're starting from I plus 2, and we can be the end of the list. So now I can range from 0 and 1 because length is 3, so 3, 2 can be 0 or 1. Great. And then J in this case would be range from I plus 2, which is, in the first case, would be 0 plus 2, so it's 2 all the way to the length of L plus 1, which is 4. So 2 and 3, or just 3. Great, I'm actually satisfied with that. So let's, and then we just check to see if the sum of that sublist is exactly equal to answer 1. If so, then we record answer 2, which is the minimum of that list plus the maximum of that list, and we break. If we've discovered the answer, then break. Yeah, pretty satisfied with this. Can't believe that I got top 20. I think that might be the best I've ever done on an Advent of Code day in the last 3 years. So yeah, thanks for watching, and I'll see you later.